do is we're going to do multiple angles. So all that means is that there's a number inside there with the x. Now you need to solve the problems in order. Again, if I had a square root, you don't start taking numbers out of the square root. You get rid of the square root, then you solve the numbers inside the square root. You do the same thing with this. The biggest problem I see is people start, they'll start dividing out this 3. You can't do that. You have to get rid of the sign first. Okay, so if I was solving this, what's the first thing I need to do? Square root it. So this can give me plus or minus square root of 2 over 2. Okay, then I need to find the places where sine equals square root of 2 over 2, positive or negative. Okay, that's going to happen at all the pi over 4 spots. Now, the difference between this and previously is this is our answer. Yep. At this point, the 3x isn't even important. So you find the y where it's 1/2? Yes. So the 3x hasn't even factored into it yet. The 3x is still just sitting there. Radical 2 over 2 comes from square rooting the 1/2. If I square root 1/2, that's square root of 1 over square root of 2. So it's 1 over square root of 2. So then I have to move that square root of 2 up to the top. Yep. Again, that entire thing should be plus or minus. Okay, so now, again, that entire problem, I just go ahead and solve it like normal. You don't deal with the 3 until your very last step. Now I can deal with the 3, because now the 3 is by itself with the x. So now what I do is I divide both sides by 3. What that means is I'm going to divide each thing up there by 3. So if I take pi over 4 and divide it by 3, that's pi over 12. 3 pi over 12, 5 pi over 12, and 7 pi over 12. Plus or minus, 2 divided by 3 is 2/3. So I get 2 pi over 3 in. That gives me all of my possible solutions. So all my solutions are in that set of parentheses. Another solution would be I could take pi over 12 plus 2/3. That would give me another solution. I could take any of these out of there plus 2/3. I could take 2/3 times 2, so that would be 4/3. So I could take pi over 12 plus 4/3. That would give me another solution. Does that make sense what we're doing and how we would get those solutions? Because if I was asking all the solutions between 0 and 2 pi, there's actually going to be a lot of them. Because this here doesn't even go up to pi. So I'm going to be adding that 2/3 a few times in order to get all the way up to 2 pi. All right, so I did an example. So this is your answer for this one. Because this one asks for a generic solution. Okay, on the next one I did one with asking for answers on the unit circle. So we start solving. Again, first step is to get cosine by itself. So I'm going to add the 1 and divide by the 2. Yeah. So add the 1, divide by 2, I get cosine of 3x equals 1/2. So where on the unit circle does cosine equal 1/2? Well, it's going to be at pi over 3 and 5 pi over 3. Okay, now I divide by the 3. Whenever we do our generic solution, we always do the plus or minus 2 pi in. Because that means that I can keep going around this circle however many times I want to. Because I actually have infinitely many answers. Now, I know this one asks for specific solutions, but I want to start with a generic solution. Because whenever I divide by the 3, I'm going to have to use this to get more than just what's here in these parentheses. You're going to see that here in just a second. So I have to start with the generic solution and use the generic to create my specific solutions. So now x is going to be pi over 9, 5 pi over 9. Okay, now I need to start using this. Now I don't want to use the minus because the minus is going to put me less than 0. So I don't have to use the minus. So I'm going to start using the plus. So I'm going to take each of these and I'm going to add on one of these. So plus 2 pi over 3. Well, that needs to be ninths. So that's going to be 6 pi over 9. So I get 7 pi over 9. Is that still less than 2 pi? Well, 2 pi is actually 18 pi over 9. So 2 pi, if I change 2 into 9 ninths, that'd be 18 ninths, right? So I have to keep finding these until I get bigger than 18 ninths. Two pi. Remember, I'm finding all the solutions between 0 and 2 pi. Change 2 into a fraction with 9 on the bottom. So if I take 2 times 9 over 9, that would be 18 over 9. Yeah. I'm going to have to use both of them, so might as well start with the small one. Yeah? Yeah. I mean, we want to do this kind of methodically because we want to make sure we don't miss any. So I'd start with the small one and then move up to the next largest one. Because again, you want to make sure you don't miss any. Since we're dealing with ninths, I'm just going to keep adding 6 pi over 9 instead of doing the 2/3. So that's going to be 11 pi over 9. So that one's still small enough. Okay, now I can go all the way back here and add on 2 of these, or since I've already added on once, I can just take this answer and add on another one. That would be the same thing, right? So I could take 7 pi over 9 and add on another one. So 13 pi over 9, that's still smaller than 2 pi. So that's yet another solution. And then let's see, 11 pi over 9 plus 6 pi over 9 is 17 pi over 9. That's yet another solution. Okay, if I take the 13 pi over 9 though, and add on 6 pi over 9, that gets me too big. So that's no longer a possible answer because now I'm bigger than my 2 pi, so I know I can stop. Yep. Because I have to find all my possible solutions between 0 and 2 pi. So whenever you start dividing this and this starts turning into less than 2 pi, that means you can have multiple angles on your circle. You can have a lot more angles than what shows up here. This will still create it for you, so you don't have to do any more to your general solution. But whenever they start asking for specific solutions, you have to start doing more. Okay, you okay with that? Now, it's not a whole lot more. I mean, it's just adding, but it's just more work. Okay, 2 more. Okay, again, with this one, we need to start off by just getting the tangent by itself. So I subtract the 3 and divide by 3, so it should be equal to -1. Okay, so where does tangent equal -1 on your unit circle? Three pi over 4 and 7 pi over 4. Now this one, what do we need to do to solve for x? Yep, multiply both sides by 2. Now, if I ask you for specific solutions on this one, if I ask you for a solution that is on the unit circle that is between 0 and 2 pi, what would it be? It wouldn't even be everything inside your brackets there. It would just be 3 pi over 2 because 7 pi over 2 is already outside your unit circle. And on the end there, you're not even adding on 1 circle. You're adding on 2 circles every time. So if you were asked for a specific solution on this one, you'd only have 1 answer, even though you have 2 answers in here. Yep, 7 over 2 is more than 1 circle. Okay, the last one's not even a multiple angle. It's, well, you'll see. Okay. So to start with, I have 2 trig functions, so what do I need to do? Pythagorean. Secant squared is what? It's tangent squared plus 1. No, it is. It's 1 over cosine, but that doesn't help me. I can use Pythagorean, though, and turn it into tangent. So then my entire problem just has tangents. So then I can get it set up so that I can factor. No, go ahead. Okay, so 2 numbers that multiply to -3 and add to -2. Yep.
What happened to the -4?
-4 plus 1.
Gotcha.
Okay, so then tangent of x minus 3 equals 0. Tangent of x plus 1 equals 0. Tangent of x plus 1 equals 0. Let's go ahead and do that one. So that's -1. So when does tangent equal -1? We just did that. 3 pi over 4 and 7 pi over 4. Okay, when does tangent of x equal 3? Yes, it does. Yep. Just not on your unit circle. So how do I solve it? That's how I solve it. Don't forget, if it's not in your unit circle, which can occasionally happen, which actually happens more often than it is on your unit circle, just remember, most of your problems here are specifically made so they fit on your unit circle. We just use the inverse. Okay, but remember, that only gives me one solution. How do I get the other solution?
You use the cotangent?
No. Oh, we have to be smart about this. We have to look at this with tangents. Where's my sheet? It's different for each one. So you have to think about it. With tangents. So let's see. Tangent of 3. I have no idea where that's going to be. But wherever it ends up being, whenever I take an arc tangent, of, let's say, 45. Or of 1. Let's say I take the arctangent of 1. Where is the equivalent arctangent? Where's the other place where tangent equals 1? 5 pi over 4. Okay, so let's say that I take the arctangent down here at -1. Where's the equivalent place? 3 pi over 4. Okay, well, let's stop using, fancy ones, the 45-degree ones. Let's take the arctangent here. Where's the equivalent one? 5 pi over 6. Notice that they're directly opposite. Okay, so let's say I'm at pi over 4. How do I get to 5 pi over 4? What can I add or subtract? Pi. I can add pi and get there. If I'm here at negative pi over 6, how do I get to 5 pi over 6? Add pi. So, wherever I take this arctangent of 3, how do I get to the other one? Now, I'm totally okay. I wrote it like this just because I don't have a calculator sitting here with me. I am okay with you doing the decimal answer. I just didn't want to take a time to go find a calculator. If you want to do the decimal answer, do the decimal answer. If you want to leave it as arctangent of 3, leave it as arctangent of 3. Doesn't matter. I don't. Not if it doesn't ask for it, because I didn't ask you up here to find specifics. Either way, this gives us all of our answers, right? We found the two places on the unit circle, and then we said plus or minus 2 pi n, so this will give us all of our answers. If we wanted specific ones, then we could calculate the specific ones. Yes, you have homework. What kind of math teacher would I be if I didn't give you homework? When have I ever been kind to anyone? In fact, I saw a banner yesterday I'm going to put it up in this room. It says, the beatings will not cease until morale improves.
I'm not opposed.
That's like a famous pirate quote. Yes. It was hung up inside his engineering lab. It was awesome. I'm getting it. That fits this room perfectly. I say being nice is one thing that no one has ever accused me of.